going to get started with SQL. So just before I actually mention this and go deep into the session, I want to mention that this series is a 4-part series. It aims to introduce you to databases with Python. So we're going to start with this session, which is an introduction to the theory behind SQL databases. SQL databases are actually like a major topic. So if you study computer science at university, you might take an entire course. If you do a boot camp, this could be like a really big topic. So we're going to try our best to cover as much as possible in 2 sessions regarding SQL. So this session and the next one. This one more theory, the next one more code. And then we're going to move on and do a MongoDB session, which is a NoSQL database. You'll learn what that is soon enough. And then we're going to do a Firebase database. So that's like an overview of the coming sessions. Now for this session, what are we going to cover? We're going to talk about databases in general, what they are. We know many of you here are new to this. You may not have worked with a database before, so this is definitely a very beginner-friendly area. We're going to go specific into relational databases, which are related to SQL. And then we're going to talk about SQL. So without further ado, let's get started. So actually, before we can start talking about databases, it's important to actually talk about data. So really recently, you can hear this a lot. They say that data is the new oil, meaning that it's super valuable and people are talking about it. Companies want to invest in it. People are paying money for it. But what do we really mean by this? So an example of data is what you see here on the screen. You can see a woman. So this woman represents a user. And there's all this data about her. So there's her name, age, her address, her occupation, and even more, technical specific things like the pages she's clicked, the products she's bought. And why do we really highlight this? Because this data about you is actually quite valuable. We know we all have this fear that, companies like Amazon or Google are actually stealing our data and doing all these really crazy evil things with it. And now I do agree, it is an invasion of privacy. But what they're doing is not really stalking you. They're pushing your data through an engine that ends up recommending things to you. So, so that's like, sorry, okay. Okay. So that's really a like overview of what data is and why we really care about it. And the reason that we want to talk about databases actually, so taking this point to databases, is because this one woman you see here, this data you see around her, this is available in billions of data points. So, there's billions of people on social media, billions of people buying stuff on Amazon. So there's so much data to work with. And that's why we need databases. So as you can see here, messy data does not really help. So whenever there is messy data, we can't really benefit from it. Companies cannot use this data to sort of, to actually exploit it and perform different things. Some common problems in tech are data storage, data management, and data organizations. How do I take this messy data and make it nice and organized so that I can actually process it and actually use it? And this is where databases come in. So databases, this is what we're talking about, right? This is our session. So what is it? It's actually an organized collection of data. So we have all this data that we were talking about, be it data about people, user data. Maybe a bank is storing its records, an insurance company is storing information about its clients. There's data everywhere. A hospital might have a database of, all the patients and their cases and their doctors, a gym. So this can be an endless list of things that have a database. And if you're going to develop software for any of these different clients, so a hospital or a gym or a bank, you're going to need to somehow organize this data in a database. So like we said, it's organized. It's similar to an information system, meaning that it stores this information, and we use it to save, organize, protect, and deliver the data. And this icon you see right here, this is actually a database icon. You're going to see it a lot in different logos for different databases. Okay, so next up is database management systems. So we said the database is like records and information. It's an information system, basically. But what is a database management system? This is a piece of software that it's actually a heavy piece of software that enables you to manage a database. And why do we really use it? Because I'm going to give you a scenario. Let's talk about file-based systems. Let's say you are a bank and you're saving all your information about your clients. So what you do is you open up Word every time, like Microsoft Word, and you type in name, John Smith, and his age is that much, and he owns how many bank accounts, and this and this and this. You may make typos, you may have really redundant information, and then you might lose track of all your different Word documents for all these people. And when you have billions of users, this is seriously not sustainable. So this is why we want database management systems. So we ditch the files. We don't want to do files and folders and all those hierarchies. We want to use a DBMS. So what is it, a DBMS? We said it's a heavy piece of software. And we say heavy because it is seriously heavy, because it's not just a text file or something. It helps you manage all of these different data points, all the different views that you have, and we'll talk about those later on. There are multiple popular DBMSs. So the ones you see here are probably the most popular ones. So you have MySQL, PostgreSQL, SQLite, and the Oracle. Oracle is mainly used in like super big companies. Like you might not want to learn Oracle on your desktop PC and start practicing. Now, for beginners, I would say SQLite is the by far simplest to learn. MySQL or PostgreSQL are also, good things to start working with, especially if you want to be a web developer. Okay, so now you know what these things are, what a database is. What types of roles are in a database environment? So here I'm talking about jobs as well as just roles in the terms of like responsibilities. Maybe if you were at a company, you have certain responsibilities regarding the database. So a database designer is a person who actually designs the structure of a database. This right now might seem a bit vague because we haven't really gotten into how we design databases, but usually there are people dedicated to designing a database to ensure that it's optimal, that it's the best possible version of the database that we can have. You're investing lots of money into this data, into this database. You want the best one that you can, the least storage space, and all that. A database administrator is someone who just manages the whole thing. Like this person runs the entire database stuff. This person gives permissions to different people. So this person is like, okay, person X, you're allowed to actually access this data. Person Y, you cannot access this data, but you can add new data or something like that. So it's like a management job for a database. The next thing is developers. So a lot of you here probably are interested in this one specifically because you want to develop websites or you want to use Python to build certain applications. And developers also actually work with databases. They take the databases, they connect it to their backend, and they start working with it. And that's really one of the things that you should learn as someone who's trying to be a developer. It's not really restricted to a database administrator. And finally, the end user. The end user is, for example, you. When you're scrolling through Instagram and you're seeing all these photos, you're accessing information from one big database somewhere worldwide. And this big database is storing all those photos and all this information, like the photo, the comments, who has liked it. All of this is stored somewhere on a server somewhere in a database, and you're the end user accessing it. So these are different people in a database environment. I can stop for like a bit of questions if there's any anyone has a question. I might be going too fast. Okay, let me see. Yeah, we're going to share the PowerPoint. You'll see it with the recording, I believe.
I think everyone's okay, Hala.
Yeah, okay, I realized as much. Okay, so now that we've spoken about a database and a database management system, it's important to talk about relational databases. And what are relational databases? Or before that, why relational databases? Because this is an SQL session. So SQL works with a special type of database, which is a relational database. And according to Oracle, a pioneer in databases, it is a database structure to recognize relations among stored items of information. So here's an example. We can see here that, okay, so we can see here that we have, this really nice graphic, stuff is pointing to each other, and, maybe it doesn't make sense to like someone looking at it from outside. But internally, what this really means, it follows a specific format to design a relational database. So here you can see that there is, for example, users in this database. There's ratings, there's movies, there's tags. What this represents is basically different users' ratings related to movies. And we're going to delve deep into this structure and how we build it later on in this very same presentation. Okay, so like we said, it's a special kind of database. How does it really look like? Data is usually in the form of tables. So if you used Excel before, this might sound familiar, like, isn't this the exact same thing? It's kind of similar, actually, if you think about it. It's sort of a database because you're storing data in rows and tables, but there's a bit more to it. So here you can see that I have a database of employees, for example, and there are two records in this database. So I have an employee ID, which is E43001 or something like that, for John Smith, and his address is in New York. So you can see that this person is a record in the database. So this is how you exist somewhere, maybe in governmental records or the records for a bank. Your information is stored like this in a record. And we can see that this really is a relational database. The tables have rows. The rows contain information, and these information are defined according to the column labels. So you can see here that John, Smith, New York, this all relates to the specific labels for the columns. So John is a first name, obviously. So this is how it works. And relational databases follow a data model. Remember before when I was saying that there are specific roles in a database environment related to database design? Someone has the job of designing. This is that person's job. That person is tasked with designing this specific diagram right here. Now, it might look complicated, but it's actually really easy. And we're going to follow through an example that tells us how we can design such a thing. So here, what we can see is basically different information, and they have different relations. And the data model, while it does not hold any data, so this model does not have information. What do I mean by this? That you don't see John Smith somewhere in this. You just see username, password, email, things like that, because this is like a high-level representation. The data model is actually, I would say, one of the toughest parts of learning SQL, because getting used to the language of SQL and querying and working with the database can actually be fairly straightforward. But designing it is actually kind of difficult. Now, the good news is, most of the time, if you go to work for a bigger company, you're probably not going to be tasked with designing this. So you're just going to be there, you're just going to be reading it and trying to understand it. So there's no need to feel like scared. Okay, so yeah, I went on about that, but yeah, this is basically a data model. What it does, the data will follow this structure. So this represents the data. And this is really what a relational database is characterized by. This is what makes it special. Okay, so should I stop for questions, or let's see? Anything? Okay, so thank you guys. I see good comments. Let me see. Okay, yeah. Okay, so now we know what a relational database is. What is SQL? Because we told you guys you're here to learn SQL. Maybe by now you haven't heard those terms yet, and you're like, okay, what is this about? So SQL is a language. It's somewhat a programming language, you could say, that you use to talk to your database to get information about it. So we said the database, it has all this information about maybe the user or something like that. So let's say the database has all the information about, John Smith. and I want to find out what John Smith's age is. There might be ethical concerns about that, like you shouldn't do that, but okay. So to do that, I would use SQL to access John Smith's information from the database and find his record within a million entries. So this is what we use SQL for. We can also use SQL to code things like creating the data, updating the data, and deleting the data. So CRUD operations, create, read, update, and delete. Okay, so to use SQL, we need to understand two things. Firstly, its syntax. So SQL has very specific syntax and the way it works. So just like every programming language, you are gonna have to learn some syntax. And second, how it works with the database. So we said it's talking to the database, it's getting information. How does it work with the database? So we're gonna see how all of that works. An example of SQL is the following. So this is SQL code. And let's actually read it and see what it means. So here's what we're doing. So we select the attendee name. By the way, SQL is a lot like English, so it's very intuitive to understand what's going on just by reading the code. Like I said, the actual syntax is not difficult with SQL. It's very straightforward. So we want to select the attendee name from the event registered. So from a database of events that were registered. The from syntax tells us where I'm getting this information from. So I'm getting this information from the event registered. And I'm selecting the attendee name, where location is Amsterdam. And then let's forget about the order by for now. So basically what I'm doing is I'm going to this database of events. I'm getting all the names of the attendees who were registered in Amsterdam. And I'm doing this through programming, through SQL. And it's just like saying, I want everyone who was registered in Amsterdam. So that's really how this whole dynamic is going. No worries if this is still a bit vague, because we're gonna go in depth into the syntax next session. So this one is just really setting up the entire series and talking about the theory. Okay, so actually let's see an example of SQL in action. So I'm gonna open SQLite and actually show you a sample database called the Chinook database, or Chinook. I might be pronouncing this one totally wrong, but yeah. So actually, I think I'm only sharing Chrome, so give me a second. Okay, so there should be a way to share my entire screen, I think. Okay, yeah, screen. It's right there. Okay, so I'm sharing my entire screen. Now what I'm going to do is I'm going to go to SQLite, so DB browser. It enables me to actually look at the database in SQLite. And now I don't want anyone to feel intimidated by like, okay, what is this? I don't understand. Don't worry, because like I said, we're gonna go through this in depth. We want to give you a taste of SQL before you can actually start, coding and writing stuff properly. So I'm just gonna open database, go to my desktop, actually get this sample database, and now we can go to browse data. So here I can actually look at the data. So this is stuff related to music, I believe. So here we have albums, and we can see these different albums. So different album titles. And I'm not gonna go too deep into the database and what's going on, because we're gonna talk about this later. An example here is invoices. So invoices, they were billed in certain places. We can see the billing country here. So for example, if I want to get all the invoices that were done in the USA, what would I do? I would go to execute SQL. I would select, okay, star from invoices, where country is equal to USA. And like I said, it's really intuitive. It sounds like English. I want everything. The star means everything. From the invoices, so I want all the invoices where the country is USA. So if I run it, okay, I messed up. This should be star. Okay, give me a second. All right, so let me specify okay, let's say we want the billing address. Oh my God. All right, guys, so just bear with me a second. Let's see. Maybe it's this. No. Okay. Anyways, you get the point. So this is supposed to work, but for some reason I'm getting a no such column country. Okay, that's nice. So it's billing country. You guys have to forgive me. It's past midnight. So yeah, here we go. So billing country is USA. Yeah, so now if I run this, I get a list of addresses of all, I can actually put this one at the start. I can get all the invoices that were billed in the USA. So here billing country is USA. Okay, meanwhile, in reality, in our database, we had tons of records, some were in Germany, some were in Norway, and we just were able to only extract those in USA. And like I said, this is just an example. We actually want to go deeper in SQL next time, hopefully. So yeah, so I'm gonna just go back to presenting. Sorry, that took more time than it should have. Okay. So this database that we just saw, this is the schema for it. So it's a popular sample database. We don't own it, that's just a disclaimer. It's a very popular open source sample. And this is the schema. So this is the data model. Like we said, it's the design that enables the data to follow this design. And we're gonna try to design our own database and see how that goes. Okay, so we've been talking about this for a while. How do we design a relational database? Before I start talking about this, are there any questions? So anything relevant that we should take up?
Hala, there is a question in regarding keys. I believe it is about primary key or foreign keys in Q&A box.
Yeah,
Explain
yeah,
about
we're gonna
selection of proper keys.
Yeah, we will cover those.
Okay.
Okay, so we'll cover them, and if it's still unclear, then we can take up the question again. But yeah, we're definitely gonna go over it. Okay, so how do we design a relational database? So this, scary thing that you're looking at here, how do I actually draw this? Now, it doesn't really need to be this detailed anyways, with like keys and everything. So, but we'll still talk about it anyway. So here's the procedure. Think of it in 4 steps. The first step is to think about your data. So if you're a developer, obviously there is a client, or if not a client, there's something your boss told you that you should be doing. So you're building this application for a bank, for an insurance company, for a car company, for a gym, depending on the case. So if it's a car company, you're gonna start thinking about the data you have. I have cars, cars have different brands, and I'm not sure, I'm not really into cars. So things like that. After you think about your data, while you do that, you want to really talk about the objects that you have. And we'll talk about this in more detail as soon as we get to the example. Okay? And then you want to actually list them and their attributes more formally. When I say formally, I mean like actually creating a list of things like, okay, the car has a car ID maybe, a car license plate number. Every car has a license plate, so we can identify it. It's the same thing in the database. So it has a number, it has a brand, it has a color, and different information about this car. So you want to start listing this and writing it down. Then you start maybe setting up tentative tables with examples. So you put some sample data and you see how it looks like, how the data is working. And then finally, you would draw your schema. You can maybe not even draw the schema at all, but depending on the size of the project. Okay, so let's have an example. We're gonna design a database for a bank. The first thing we're gonna do is follow step 1. We're gonna think about our data. So what objects do I have? What do I know about those objects? And how do these objects relate to each other? So let's see. We're doing this for a bank. So what objects do we have? Well, this is a very simplified example, but let's see, we have a client. People come to the bank, they put their money in, and they use the bank's services. We have a bank account. So the bank account is, everyone has a bank account. The credit card, so you might have multiple credit cards associated with your bank account. And for every client, there's an employee at the company that handles this client. So obviously when you go to the bank, there's someone there who's going to talk to you, and they're maybe going to handle your file or something. So these are our objects. Kind of in these objects, you should think of those as they will guarantee that these will have a table. So there will be a table of clients, a table of bank accounts, a table of credit cards, a table of employees, and they're all going to be linked together to make some sort of relation. This is why we call it a relational database. So what do I know about these objects? Let's see. The client, we want to know maybe his first name, last name, age, the employee that handled this client. So if I go to the bank, there is obviously an employee who's going to handle me, and my bank account number. The next thing is, for simplicity, we're going to assume everyone has one bank account. The next thing is a bank account. It has the client, so it obviously belongs to someone. The cards, some cards are associated with the bank account, and there's an account number. And I'm sorry if I'm boring you, but this is actually part of the process. So you have to actually dig deep into your client and think about what they really want and what their data looks like and what objects are in this data. So the credit card, the card number and the amount, the account to which the card is associated. And finally, the employee's first name, last name, and age. So this can be completely random, can have different things. Okay, this is step one. We thought about our data, we wrote down our objects, and we wrote down what we know about these objects. Next is step two. So we want to list these objects and their attributes. We want to think about their types while we're at it. And we'll say what we mean by types in a second. So the client. The client has a client ID, a first name, last name, and age, and employee ID. And I'll go in detail in a second. Bank account ID, client ID, and we'll talk about the red stuff, no worries. Credit card and employee. In teal, so the stuff you see here, the IDs, are actually primary keys. So we received a question about primary keys. I hope I can be able to address it. So primary keys are basically identifiers for your data. Your name is Jane Doe. You go to the bank, and the bank holds a record for your information. But then there's like 50 other Jane Does. And one of them is a millionaire, and the others are not. And then suddenly no one knows who owns this $1 million. It's for one Jane Doe, and no one knows who it's for. This is why we use IDs. Names are not enough. Names are not nearly nowhere unique. So for sure, we need to use an alternative. And that alternative is a primary key, and it is the ID. So here we created a client ID. We could have created a different type of primary key. Maybe we want to use unique usernames. You know, some websites, they only make you do unique usernames. But anyways, you have this unique ID, meaning for client, the first Jane Doe, it's going to be maybe something like 001. For Jane Doe 2, it's going to be 002, and things like that. So different identifiers. Every single table needs a primary key. So every table needs a primary key to be able to identify its different records. Otherwise, the data will be all messed up. This is one of the principles of SQL and of relational databases. Okay, so these are the primary keys. Now, what about the things in red? Okay, so the things in red are actually things that maybe are related to this, and they could have been included as attributes, but we did not include them, and we'll explain why. So the client, we said we have all this personal information about him. The first name, last name, age, employee ID, so the ID of the employee who handled this client. What about the bank account? Why don't we want to associate the bank accounts directly here? This is because the bank accounts are their own table. So the way you want to think of this is not this client has this information and this bank account. You're going to think of it as there are these bank accounts. Maybe bank account 1 is for this client, bank account 2 for that client. Why do we do it like that? Because there might be multiple bank accounts per client. So if you're in a table, you can't really tabulate that if the first client has 1 bank account, the second one has 50. And I'm sorry if I'm going a bit too fast. So I hope it becomes clear in a second. Okay, so in the second case, same thing. So why don't we include the cards in the bank account? Because the cards are actually their own database. So they are on table. Because you might have multiple cards and each card will be associated with an account. Okay, so let's actually start looking at the data and trying to see how this is working. Okay, yeah. Okay, so here's our first table, for example. So the same attributes we listed in this slide. So we listed client ID, first name, last name, age, and employee ID in this first slide. In the next slide, in step 3, we started putting it in tables. So define your tables and start setting up sample data. So this is fake data that we're using to help with the process. Okay, so we have John Smith. Sorry, I use very generic names. We have John Smith. His client ID is 24001. So this is obviously always unique. SQL will not let you save the same ID twice. So this is an identifier. It has to be completely unique. This is what we mean by primary key. So John Smith, primary key, their ID is 24001, age is 43, and employee ID is 301. And we'll see what that means in a second. So you can see here that there's all this different data that's stored in the table. Now let's look at actually the employee table. So the employee table is a whole different table, different information. It has actually our names, so the team who prepared this presentation. So Karen, me, and Ramya, we all work at the bank, and the ages are obviously incorrect. But yeah, so these are the employees at the bank, and they have these different IDs. So you can see here, so let me move this, okay. So you can see here actually that these employee IDs correspond to these employee IDs here. And what this is a foreign key. So employee ID is a primary key in the second table, in the employee table. It identifies the different employees. So Karen has an ID of 301. I have an ID of 302. And when John Smith comes to the bank and he gets handled by Karen, what happens is his employee ID, so the person who handled him, is 301. And we call it a foreign key because it's pointing to the other table. So what it's doing, it's basically, rather than here, writing down John Smith, age 43, employee Karen, something, her age is, and then having so many different records of all her information, what it does is simply store the ID of the person who handled John. And the same thing goes for Mary. So here, Mary was handled by me, so by ID 302, and obviously it also points to the employee ID in the employee table. So this is a foreign key. And I'm gonna stop for questions here because I feel like this might be a bit confusing. And understanding this, I really believe is the core to understanding the whole thing. So once you get this, you get the entire schema stuff that's going on, and you start to really understand the structure. So do we have any questions? All right, give me a second. Okay, sorry about that. Okay, so no questions. I guess we'll continue. So that's it for step 3. Now, obviously, we have 2 other types of tables. So I'm just gonna scroll back here. So we had the client, the bank account, credit card, and employee. So we just saw client and employee, and we saw how the foreign key relationship works between the two. So this is how the two work together. And this is how we use one column in one table to point to an entirely different table. And when I say point, this means like point, like with the arrows that you can see. This is why we draw it like that in the schema. So step 4, we said, is to draw the schema. We said we can get away without doing this, but we're actually going to do it. You know, this is a simple example, and it would be useful. Okay, so now we have these 2 different tables, and we said that the employee ID points, the employee ID of the client points to the employee ID in employee. This basically gives us information about which employee handled a specific client. When we draw the schema, it looks like this. So this is just a very simple schema. It doesn't really have anything complex. This is just a way of representation. So I want you to understand that this does not change the way you write your SQL. This is how you're just gonna model your data. You're gonna show this maybe to your boss or to someone at work, and you're gonna say, I wanna do the database like this. So I designed this. And they're gonna be like, okay, and then you're gonna go on and code your SQL. But this is just a way for you to represent what you want to do. And here it's basically doing the same thing. So what you're doing is you're listing your attributes again. So we said the client has a first name, last name, age, client ID, the primary key. And it also has the ID of the employee who handled this client. And what we're doing, again, we're pointing to the employee, which is the same thing. It's like a box. It has the title of your object and the different attributes that this object has. And that's really how this idea works. So this is a foreign key. It points to a key in a different database. And I'm aware this is very confusing. So don't feel discouraged if you're here and you're like, okay, I don't get what's going on. So that's really how the foreign key is working. So again, the primary key is a unique identifier. So the one in green or teal. So it's a unique identifier. It makes sure that your data record is unique. And then you can use it to perform different links between the tables. So like we saw before, so actually I want to stress this because it's important. Both John and Jane, they have an employee ID of 301. What this is basically doing is that it's telling us that they were handled by the same bank employee. They were both handled by Karen. And this could grow to be really big. So, Karen has been working there for 10 years. She's handled about 200 different clients. So you're gonna have 200 different clients in the database, all of whom have an employee ID of 301. So this is how the foreign key works. And this provides information about this employee. So if later on, so remember when we were doing the SQL example, we got all the different invoices that happened in the USA, I can maybe later on get all the different clients that were handled by Karen in her time working at the bank. That's really the goal here. And yeah, that's how we designed this schema. So this is how we're drawing it. And now we can go back and continue designing the entire bank. So this is how we started. We had the employee ID doing this pointy thing, so we've spoken about that now. And then we still have the credit card and the account number to add to the database. So yeah, so Ramya, Karen, if there's any questions, can you guys let me know because I can't really see the Zoom.
Hala, I think we have two types of questions. So
Yeah.
in case you want to go through. So if more is really about the foreign key and the schema. So the foreign key, one of the ladies is asked so when you have a foreign key, so it references another table, then you go to other table. So is the foreign key on table 1 a primary key on table 2?
Yeah, definitely. Yeah, exactly. So here, and this is, it's not a question because you answered yourself. Exactly. So employee ID here is a foreign key. Foreign key is it's foreign. It's something from the outside, when you think about something foreign. So it points to something on the outside. And here in the employee table, employee ID is actually the primary key. It's an identifier. I'm going to give you a different example here, and hopefully this highlights this. For example, let's say both employee ID 301 and 302 were both named Karen. And now, imagine if rather than pointing to employee ID, we're just storing the first name. Now we're just confused about which Karen handled which clients. So obviously the foreign key should point to something that is unique. And what is unique? The primary key. So in the first table, it's a foreign key. In the second table, it's a primary key. Yeah, I hope that answers your question.
I think the ladies want to also go through about the primary key and the foreign key a little bit more again. So I think they digest it properly, if you don't mind.
Yeah, no, for sure. Okay. So I'm just gonna backtrack a bit because I'm aware this can be, somewhat confusing. So here we listed the different attributes for each object. So let's just go back and think that Objects represent certain data points. So, at the gym, you would be storing all the members who are registered in the gym, right? At the hospital, you would be saving all these different hospital records about patients and doctors and medical scans and all those. So here, we're doing this specific example for a bank. So we're storing information about client, the bank account, credit card, and employee. This is what an object is. An object, it's the table. So the object will be represented by a table. Next, for each table, there are columns, right? So we said that each table, it looks like this. There are rows and there are columns. The columns have labels, and they're labels for the rows. So it's a lot like Excel, it's a lot like, it's very straightforward. So rows and columns, right? How is this represented here? The columns are the attributes. So I've been throwing around the word attributes, but basically what it refers to is the columns. So for client, what are the columns? We have client ID, first name, last name, age, and employee ID. Let's ignore the red stuff now. So we have those 5 different attributes. Why do we need something called a primary key? So a primary key is a unique identifier. Going back has a client named Jane Doe, but it also has 50 other clients. We have $1,000, and then you're confused. So which Jane Doe owns this bank account? You cannot use the first name and the last name. That's really what I'm trying to get at. This is why you need an ID. Can have the same ID. It's ID, identifier. It's like a car license plate. No 2 cars will have the same license plate. And that's what a primary key is. So there is one for every single table. You can see a green one for every single table. You will never not be able to identify the different rows. Like I said, you're a user, you're on Instagram, and you go to your feed and you see your own photos. But obviously, your photos are yours, So at some point, what's happening is the database is getting all your photos. And how does it identify you as a user? Through your ID, through some identifier that you have. Just like you have a passport number. No 2 people have the same passport number, right? No 2 people have the same car license plate. This is the same idea. This is what a primary key is. Now, a foreign key is like a link to the primary key. So let me see here. Okay, so it's a link. When, let's say, you have information about the cars and you store the license, your car has any, I don't know what car people do check, like, okay, whether it has any like fines or something for speeding like speeding tickets, right? And you want to check for this license plate. It's like a different table, right? So there's the table of cars and all their license plates. Then you have another table of like speeding tickets and all their license plates. And you use that plate to know which car has a speeding ticket. Things like that. So a foreign key basically is in another table and it refers to this table. Here, what's happening is all these clients are coming to the bank and they're each being handled by one employee. We just want to know who this employee is, right? So John was handled by employee 301, Jane as well. Mary was handled by employee 302. And in reality, let's say you didn't have this table right here, right? So let's just cover this. You don't have this. What does this mean? What does 301 mean, right? It has no meaning. This is why we have 2 different tables and a foreign key and a primary key. So I hope it's clear now. I know it can be super confusing. So let me know if I should go over it again. Or like if there's any other questions.
So Jeanette actually asked an interesting question. So we talk about the employee, each employee assigned for one customer, right, for one client ID. So what happens if the two employees are giving services to the same client? And the second question is like, how are they related to the database in terms of a foreign key?
Yeah, that's actually a great question. So actually, if you go deeper into the theory of SQL, you realize there are different types of relationships. There are one-to-many relationships, many-to-one relationships, and many-to-many. Now, this here is actually many-to-one. So one employee has many different clients, and for each client, I don't want to like trespass and confuse everyone, but there's many clients, and the many clients, you know, each have one employee. So the same employee can have multiple clients, right? So Karen here has two. But what you're talking about is a many-to-many relationship. So John Smith has multiple employees servicing him throughout his entire being a client at this bank. This would entail a totally different design. So, like I said, designing these SQL tables is actually quite difficult, and it's very unique to the specific data that you have. So we say understand your data, like thoroughly understand it, cover the cases. What you just did is actually a great and a classic example of someone who has thought of all the possible cases that you might have. So one of us may have been fired from the bank, which is a good idea. This means that we'd have to change this model. We would need maybe a third table, but that's really a bit more advanced. But just know that you're on the right track because you're thinking of all the different cases. And it's just a different type of relationship that you're talking about. I hope that helps.
I think they're all good. They're all better now. That's good. That's good. Thank you. So second question, a second type of question about schema. So refer to slide 23. If you want to go to 23 for a second.
Okay, just
take your time.
Here, okay.
Yeah, so there are two types of questions. So they want to know, I think the audience is a little bit confused about the data model and a schema. Also, can you explain a little bit more why this is a common schema for like a database? They want to know like why is it so common?
Yeah, okay. Actually, regarding the second question, it's not like this schema itself is not common. It's for specifically this a specific sample database that Chinook, Kainuk, I really don't know how to pronounce this. Yeah, so this is a schema for that database. When I said the word common, I meant the format. So if actually you just go back here to what we were doing when we were drawing our schema, no, where was it? Okay, here. You know, we had like the client title, then client ID. We were saying it's an integer, so the ID is obviously a number. First name is a character sequence, last name is a character sequence, and so on. So this is our format. What this is just another format, like it's just a standard, you know, like here, they highlighted the keys using an actual key symbol, as you can see. In our thing, when we were doing it, the very basic thing, we highlighted it with the teal color for women who code. So it really depends. So this is just like a formatting thing. It's about taste, but you don't really need like to have this specifically. Like we can just say schema SQL, and you know, come here, and you're gonna see like a trillion types of formats. So this is different, obviously. So don't stress about the format of it. You can do simple squares, just like we did. So yeah, okay. Now regarding the first part, I think the question was about like the data model, like how does it differ from the schema? It's the same thing. It's just a representation for what we're doing. So think of yourself like an architect. You're designing a building, and then the civil engineer comes in and they take your design and they implement it and they build the building from the ground up. So this is something like that. It's an architecture, a representation. You model your data, you draw this, you sketch it out. You might even do this on paper, and then you will go and code it in SQL. That's really what it's for. I hope that's what the question needed.
Sam actually has an interesting Interesting. Like a reference. So is the data model a relationship, while a schema is like a whole ecosystem? Would you say?
No, it's the same thing. Yeah. I might have thrown those two words around. It's the same thing. Like, it's actually like both. Like, both the data model and the schema, which are like the same thing, are a representation of the ecosystem of the databases and of the relationships between the databases. I apologize if that wasn't like clear before. Yeah.
No worries. I think we are good about the questions now. Sorry
Okay.
if I interrupt you so long.
No, that's fine. Yeah, so we were actually here. I'm gonna present again. Okay, so we were here and we said that this is what we reached. So we had this, object for the client, and it has these attributes, so first name, last name, age, and all that. And the employee had those. And then for each client, there was an employee who handled this client, and there was a linking between the two, right? So this is what we had before. Now we want to add the other two objects we have in our database. So we said we have a credit card and a bank account. So, okay, I may have pasted this too many times. So yeah, this is the one that we were talking about before, the client and the employee. And we said this is the foreign key. And now we have the bank account. So the rest of our data. The bank account looks like this. So it has the account ID and the client ID. So now, and I really wish like we were more of like in an interactive situation, because I would ask you, what is the foreign key in this case? What are the primary keys? I'm just gonna go ahead and answer myself, but the primary key for bank account is actually the account ID. It enables us to determine what this bank account is. And in reality, every bank account actually has a number, maybe an IBAN number, or actually like a bank account, like a Swift code or something like that. I don't know what's going on, but yeah. And this number would identify this specific bank account, and it's obviously unique. There are no two bank accounts in the world that have the same bank account number. So here it's the account ID. It is a primary key. And in the case of the client table, so this table here, what is the primary key? It is the client ID, which identifies our different clients. Like we said, we could have John Smith and John Smith again, but the ID would help us to identify and differentiate. And again, we see that arrow. This is a foreign key. And actually, let me give you a hint here. The arrow starts at the foreign key and it points towards the primary key in the other table. So think of it like that. Follow the arrow and how it looks like. It will go from the foreign key to the primary key. So that's just a hint here. And yeah, so that's really it for here. So it's kind of following the same logic that we had before with the client and the employee. But now each bank account is associated with a specific client. We see here that client 24334, who is actually Mary Jane, she has two bank accounts of IDs 553 and 554. So this is other information that you have available about Mary Jane and her bank data. Now we still have the credit card. So adding the credit card, here's what we have. So if we add the credit card, we can see that again, there is a primary key, foreign key, and they're all linked together. So we're starting to see the database in more of a bigger shape. And just for the sake of repetition, I might be repeating myself, but it's important to understand this. Here, the primary key is the card ID. So no two credit cards have the same number. So again, if you see, I'm always reiterating examples of things that are just highly unique. So no two credit cards have the same number, just like no two bank accounts have the same number. So the card ID is unique. It is the primary key. In the case of bank account, we said that the account ID is the primary key. So this here is a foreign key. It points from the foreign key to the primary key. We can see here that there are two cards associated with this bank account. So bank account 552 has two credit cards, and these are the IDs. And also for the sake of example, here the ID is actually a character sequence. It does not need to be an integer. In these cases, it was an integer, like a random number, but here it's actually a bunch of letters. So there's no like constraint against that. So you can absolutely do it. So now the relationship between bank account and client is very similar to the relationship between credit card and bank account, and actually similar to what we have with the whole thing. So now we've designed actually our entire database, because look at it now. You have a client, you know this client is associated with which employee, right? We already established that. You also have all the bank accounts, and you know all these bank accounts, which client they're for. You also have all the cards, and you know which bank accounts these cards are for. So now you have one giant linked thing. And now we only have 4 objects. So think of it in a larger organization, they have many more. And this is our final schema. So this is our final design, 4 different objects. Each object has a bunch of attributes, and the attributes, they have foreign keys and primary keys. So now, following this, we've actually taken an example from A to Z. We covered the process. We thought about our data. Our client here was the bank. We listed the attributes of our data and the information for each of these. So the client, what does the client have? First name, last name, all those things. And then we actually started putting them in tables. So the difference between these 2 slides here is this is sample data, so some tables, versus the schema or data model. And this is what we have here. And this is actually like a final design that you can present like to your boss or to yourself, just for reference. So this was our process, our 4-step process. I will take questions now, and then after that, that's really it for the theory part. I will just demo a few things with the SQLite, like just to get you excited for SQL for the next session, and that would be it. So Q&A, is there anything now?
Yes, we have 2 questions. So the first one is like, can you have multiple primary keys in one table? The answer is no.
No.
One table like has one primary key. That's what's primary key. One table can have different foreign keys, but it's only one, like primary is primary. So that's a good answer. And then second question is more like a design. Is there an app to help draw these diagrams?
Yeah.
Your amazing diagrams.
Yeah, actually there are multiple apps. I think you just have to like Google database design. One really popular one is Lucid Chart, but I believe it's like a free trial and then you have to like pay money. So I'm not entirely sure if there's like a completely free option. Oh yeah, there's one called Visual Paradigm. Yeah, so let me type those in the chat. And they obviously draw these way better than this like table stuff that I had going on. So where's the chat? Okay. Sorry, but Zoom is being like, okay, there it is. So there's Lucid Chart and there's Visual Paradigm. Okay, any other questions?
Okay, Farida, so yes, you can have multiple foreign keys in the table. Just one, remember, one primary key, only one in the table, and there are multiple, you can have multiple foreign keys. Cameron is asking any benefit or reasons for using characters versus numerical for S as a primary ID?
Yeah, okay, interesting question. Actually, the benefits are maybe in terms of saving space. So I'm just gonna go a bit off topic here and give you an example. So let's say I want to have my foreign key to be 5 characters, okay? Not foreign key, sorry, primary key. I want it to be 5 characters maximum. I'm saving storage space, like the bytes of my computer. I have very limited space. So 5 characters at most. If you're doing 5 digits, so the number of combinations, like I feel like I'm going into probability at this point. The number of combinations is way less if it's digits, because you have like 0 to 9, right? Now, if you're doing it alphanumeric, you have A to Z, and then maybe A to Z, and also 0 to 9. So now you have way more characters and way more combinations for less space. So kind of it's a benefit. So it's not really something you would really think about if you're handling like a huge database and you have all this data space. So it all goes down to design choices. Some companies have standards, like they have codes. So like, think of it like that, like employees are like EMP 001 and clients are like CLI 20, things like that. So it goes down to the company and things like that. So yeah, I hope that answers the question. Okay, anything else?
I think we are good for the questions for now.
Okay.
Let me think. Maybe we can give a little, maybe we can give a couple minutes. Do you have more to, maybe we can give a couple minutes for the
Yeah.
participant to maybe write down the questions in case they
Yeah.
want to catch a breath. Maybe I can do a little closing here and promote our social media.
Yeah, for sure.
Okay, so would you mind going to the last couple slides?
Yeah,
Thank
okay.
you. So I hope so you can catch your breath too. So guys, it was really awesome to have all of you plus Hala and Ramya here. It was such an engaging section. Love you guys participant. Love you guys asking questions. It was amazing. It was amazing, amazing. So in case you are new to us, in case you're new to this amazing group, please follow us on the social media, Women Who Code Python. We're on Instagram, we're on Twitter, and we're on LinkedIn as well. And then if your first time, we use a software called Slack to communicate on everything. So if you want, please join us on Slack. Ramya, if you could post a Slack link, invitation link whenever you get a chance. So
Yeah,
please join us. Thank you. And then we will talk about, and then you guys feel free to ask us questions there, and then you can send reach to us if you guys have any questions. And Hala has been doing amazing job, amazing job. So yeah, we will send. We will.
Yeah, we all did a great job for this. I think we were all really excited.
Thank you. Okay. One more question. On the I think on the
Yeah, I can see.
foreign key. Okay, go ahead. Like I
Yeah,
would like you to take on to that.
so someone is asking, when you design a database in Oracle, for example, do you define certain columns as primary and foreign, or do you only know by looking at your schema that a column is a foreign key? Actually, yes. This is something in SQL syntax that we're hopefully going to see in the next session. There is a, I don't want to say command, but a piece of code while you're creating your database that tells it this column is a foreign key or this column is a primary key. So for primary keys, you would say, client ID primary. So this is actual SQL syntax, and we'll be covering it in the next session in depth. So yeah, it's done through the code, and it's not only through the schema. You can not really follow the schema at the end of the day, but the code is very solid. And also, just one thing, SQL will force you to do this. So like when you define a column as primary, it's not just you and your conscience making sure that they're all unique. It will not let you have two different entries with the same ID. So SQL is really strict about this. So yeah, that's it. Okay, no more questions.
Awesome. One thing about guys, so when we post like a form to you, so please fill it out before you leave, before you go, whenever you have time. We want to understand more like a bit about you guys' background, like in like specifically in technical contents wise, so we can maybe adjust the content a little bit better for you guys. And Swati, the next section will be at, let me see, because we have three of us have a different time zone there.
Yeah.
It will be at February 17th. So it's February 17th, same time. So Stephanie just post just post a link for all the events. So we have amazing events. So feel free to join us. Check out the events we have, and
thank you, Karen. A quick one, if you could all please fill in the feedback form, which is anonymous, and that would really help us to create next content. And thank you so much, Karen, for filling that.
No worries.
Yeah, thank you, Ramya, for this.
Thank
for the
you.
feedback.
Just a quick note. So we have 4 events in total, but you have to register 4 times, like individually. So the links are on the WWCode website. So if you want to join us for the exciting journey, all 4 sessions, please participate and join us. Register for all different sessions.
Yeah. Okay. Thank you, Karen.
No worries.
Okay, so I'm not sure if people left or not. Okay, people are still here. So all I want to do is just a quick run in SQLite just to show you. So this thing that we
exciting.
Yeah. So this thing I put it actually in SQLite. So this sample data. So this one we said this is like an old thing. Let's close the database and open a new database called sample. And yeah, here it is. So this is bank account, account ID, client ID, clients and employees, and the same data that we were just designing before. And I just want to show you how we can extract certain data. So previously I was saying that we should have a way for us to get all the clients who who actually were managed by Karen at the bank. So both John and Jane, right? So how do I do that with SQL? This is I don't want anyone to feel overwhelmed, and just it's a test or a test run, just so you can see how SQL works in real time with the data that we just created. So I'm just gonna select everything from we said client and the employee. So from the 2 tables, I'm selecting from 2 tables where the employee dot first name is actually equal to Karen, and the employee dot employee ID is equal to the client dot employee ID. So basically I'm saying whenever the 2 keys, the foreign key and the primary key, are equal and the first name is Karen, I want to get who these clients are. So if I run this, I will get simply what we said. So I would get John Smith and Jane Doe from our client database because they were both managed by Karen at the bank. So this is like a teaser into SQL, like a sample run. You can get all sorts of other information. You can, for example, get the age of all your clients. Like maybe I'm a bank, I'm interested in analyzing the demographic of my clients. So I would select age from client. Yeah, that's it. And I would run this one, and I would get a column of ages, so 43, 45, and 32. And then this is where the data scientists come in. They start analyzing and doing stuff. So yeah, that's really it for this session. Thank you so much for joining, guys. I really hope you're excited about SQL now and that you're interested in the next one. And yeah, that's it from my end. I can actually stop sharing. Okay.
Hi, Hala. The quick one, we had a couple of questions on data model and schema. So we were trying to answer. Schemas are basically the structure of the database, wherein it will have column names and data types, and data model contains those schemas, and also it shows how specific tables are linked to each other.
Yeah, but essentially they're the same thing. Like I mentioned, it's the same thing, honestly, because it's a representation of your data, and it helps you just visualize how your data is all connected.
Yeah. Just because we had quite a few questions on that, I thought if anyone needs any clarification further.
Yeah. I see a question from Farida in the chat. Should we download SQLite for the next session, and how to prepare for the lab session? So we will be doing live coding. Now it is completely up to you if you choose to actually follow along and code on SQLite. But you can also choose to just listen, and the code will always be available. So we're going to be setting up a GitHub repository of all the code and the sample data as well, so you can practice and do those things. So this is completely optional. Like what you choose to do with the session, I would say is your choice. But good that you mentioned this. Maybe we can upload our sample data a while before the session. This way people can get it ready if they're interested. Okay. So yeah, that's it. Yeah, okay. If you enjoy following along, that would be great. Okay. Thank you, everyone, again. Bye.
Thank you, guys. Bye. See you
Bye. Bye.
in 3 weeks.
Yeah, exactly 3 weeks.
Remember to join us.
Yeah, okay. We'll post updates on Slack.
Yeah.
Guys, do you want to end this section?
Yeah.
And then we can. Great job, Hala. Like it was amazing. Like serious, like truly amazing.
Thank you.
Yeah.
It's truly amazing.
We all worked on this, and
it was so clear. It was so clear. Amazing job.
Yeah, like I was scared, like some parts would be a bit confusing. But
no, you were good. You were really good.
Great.
Great job. You can have a good sleep.
Yeah, it's 1:18 a.m.
Yeah, I know it's late for you. It's late for Ramya as well, actually. I know it's a little bit late for both of you. Yeah, I know.
Okay.
Yeah, great session, guys. Sorry, this went away for 5 minutes. A really amazing session. I loved all the explanations, and especially the fact that Hala stayed up to do this. So thank you so much, Hala, for doing it. I mean, hats off to you to stay up this late. And maybe we can discuss if you want to like move around the time maybe for the next session or something, because I mean, do you really want to do it this late every time?
I don't mind. Like it was the only time that would like work with all our schedules. But by the way, I don't know if I'm still broadcasting or not.
I can stop. It's fine. Yeah, I mean, I can edit the recording anyway.